Describe the likelihood of an event as impossible, unlikely, equally likely, likely, or certain. So if you didn't understand this, I would highly recommend you go back to one of the previous PowerPoints. And I think it's on slide 6 of one of them. I have put about 8 or 9 different videos. In one of those videos, was talking about the probability event line. So on the probability line, probability can be measured only between 0 and 1, 0% and 100%, which is your maximum. So if you have a probability of 2, you know that it's totally impossible because it's way too out there. Same thing as if having a probability of -1, it's also very impossible. But if you have a probability of 0.25 or 0.15, that it's closer to 0, means that that event is unlikely to happen. If it has a 50% chance, it's equally likely to happen. And if it has a chance that is closer to 1 or 100%, like a 0.75 or 90% chance 0.9, it's almost certain. So it's pretty likely for that event to happen. So when you flip a coin, we know that a coin has two sides, a heads and a tail. So when we flip that coin, we can get, if it lands on heads, means that we have 1 out of 2 chances, which is equal to the same thing, or saying 50% equal, it's equally likely. So is 50% equally likely to happen. Now, a ball contains 14 marbles. Oops. A ball contains 14 marbles and 14 red marbles and 3 green marbles. You pick a red marble. So red would be 14 over the total, which is 14 plus 3 of 17 marbles, which gives us 0.82, which I know 0.82 is closer to 1, or I can say that is 82% chance. Oh, I forgot my equal sign here. 82% chance to be likely to happen. A spinner has 10 equal sections marked 1 through 10. You spin and land on a number greater than 0. So I know that all the numbers that are on this spinner, 1 through 10, are greater than 0. So all 10 out of the 10 numbers are greater than 0, therefore 100%, which makes it's 1, which makes it a certain event. 49. A hat contains pieces of paper marked with the numbers 1 through 16. You pick an even number. 1 through 16 is an even number. So 1 is an odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 even, 7 odd, 8 is even, 10 even, 12 even, 14, and 16. So I have how many? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of those 16 numbers, which is, if I simplify this fraction by 8, is the same as saying 1 over 2, which makes it 50% chance, the same as we talked about our coins, which makes it equally likely. And our last problem, number 40. Decide if the following events are independent or dependent. So if you haven't underlined or highlighted one of these two words, you do not get the credit for it. So please make sure that you do follow through each of the steps that your problem requires. Find the probability. A bowl of fruit is on the table. It contains 2 apples, 4 oranges, and 3 bananas. David and Eric come home from school. Miss Circle just realized I made a typo there. Come home from school and randomly grab 1 fruit each. What is the probability for both to grab apples? So is this a dependent or independent probability? So a dependent probability, it means when your second event depends on your first one. So when we talked earlier about that bag of marbles, and we had 12 marbles in there, we took 1 marble out and we were not going to replace it when we took the second marble out, meaning that on the second pick, now I have 1 less marble in there. So my probability will change because my total is not the same anymore. The same idea is in this problem. So let's say Eric is the first one that comes into the kitchen and grabs the first apple. So the total pieces of fruit, I know that I have 2 oranges plus 4, I'm sorry, 2 apples plus 4 oranges plus 3 bananas. 2 plus 4 is 5, 6 plus 3 is 9 fruits in total. So I know if Eric came and got one of these 9 fruits, in this case, I have 1 less for David. Or in this case, it's showing us that David went and grabbed it first. So his probability is the 2 apples out of 9 total fruits. But now that he already took 1 apple out, in the bowl, it's only left 1 more apple and a total of 8 fruits because David already took 1 apple. So now let's set up, and when we have a compound probability with 2 events, in this case, we have to multiply them because we need the probability of David and Eric. So the probability of David is 2/9. Let me write this as a fraction, 2/9. Oh, why did that do that? So 2, there you go, over 9. And we will multiply it with the probability that Eric has, which is 1/8. So this is a dependent event. I am gonna say it's dependent. And now we will multiply these 2 fractions. We multiply the numerator with the numerator. So 2 times 1 equals 2 over 8 times 9, which is 72. And if we simplify this by 2, 2 divided by 2 gives me 1 over 72 divided by 2 gives me 36. So the probability is 1/36.